Hello, I'm Juniahn, responsible for developing Mintscan at Cosmostation. Thank you for participating in the IBC Summit workshop and showing interest. Today, I'd like to present on the topic how to read IBC on Mintscan. I'll be using Mintscan Block Explorer, which visualizes and normalizes blockchain data. Through this presentation, I will demonstrate how tokens are transferred and executed internally through the underlying logic of IBC. So this is IBC. The screen you are currently seeing in the Mintscan Hub screen, where you can observe the flow of numerous IBC data within the Cosmos ecosystem. What is IBC? IBC stands for Inter-Blockchain Communication Protocol, which is a technology that connects blockchains to enable the transfer of tokens and data between them. In addition to token transfers, IBC facilitates interaction with IBC data workers, supports technologies such as NFT transfer and interchain accounts. The IBC process is as follows. A transaction is created to transfer tokens from chain A to chain B. The relayer receives the request from chain A, verifies it, and passes it in to chain B. Chain B processes the request and returns the results. Now, you might be curious about what this relayer is and what it does. A relayer refers to a node that performs the role of transmitting data between blockchains. You can think of them as intermediaries that manage interactions and transfer data. If you go to the Mintscan Relayer tab, you will see a list of relayers like this. Here, this listed chains are blockchains connected by IBC to the Cosmos Hub. Let's take Osmosis as an example. You can see the relayers connecting Cosmos and Osmosis in Mintscan. The relayer marked in green represent commonly used relayers. The one in yellow indicates relayers that are used but relatively less frequently. There are also relayers represented by red dotted lines, indicating that they are not being used. Moreover, you can check the operation period of the relayers and the status of IBC within the last 24 hours. If you want to see more detailed information about specific relayer, you can click on it to access the details. Here's the four cards above represent the value of tokens that have been transferred through this relayer, the number of IBC transactions, the timestamp of the last usage of this relayer, and the operating period. The cards below indicate the number of send, receive, timeout transactions between the chains using the relayers. The number represents the count of transactions that have not failed and have been counted. The left side represents the target chain relayer, while the right side represents the counterparty chain relayer. Within this card, there is a label called pending. This number represents the transactions that user have sent, but the relayer has not yet processed. And it indicates the count of transactions in the mempool. If there are many transactions in the mempool, it could mean they are issued the chain or the relayer. Below that, you can find graphs showing the transfer of tokens through this relayer on a weekly basis. It shows which tokens were sent and received, and you can also check the list of these tokens. Additionally, you can view information and status about the operators who operate this relayer. The transaction list in the bottom represents the transaction conducted through this relayer. Now, let me provide an example of the most fundamental token transfer in IBC. I will use Cosmostation extension, which allows efficient utilization of interchain functionality. If you have a Cosmostation extension already, you can follow me with the IBC process. You can start the process by clicking on IBC send and send, IBC send, and set the destination chain. Each times, I will set it up to osmosis. Now, in order to send the IBC transaction through the most used channel, Cosmostation extension automatically set it up for you. Enter the address and quantity, and click send and sign to initiate the transaction. Let's take a look at how the Cosmostation in Mintscan appeared. Yeah. Depending on the state of relayer, you will see transfer transaction is successful after waiting for about a minute. Yeah, it's done. You can easily view in the transaction data such as a sender and receiver and source channel port sequence and quantity. After some time, you can see the IBC process is pending. The sending, yeah. It's not yet. I can show another example. This. Yeah, it's over. After some time, you can see IBC process in here. You can check the transaction were processed, the sending and receiving chain, and whether the acknowledgement were received correctly. While observing the IBC process, you may come across the screen like this. This occurs when multiple relayers are involved in processing. The transactions signed by a relayer are displayed in green with an effective state of 1. Its relayer is status is 1. And the transaction not signed by a relayer are displayed in gray with an effective status of 0. Let's take a look at the received transaction of the transaction you sent. Osmosis. If a transaction has successfully processed, sending a response acknowledgement, successful processing back to Cosmos complete the IBC transaction. The actual data can be found by examining the JSON of the transaction. First, let's look at the transaction on Cosmos. And JSON and log. Within the logs, you can see the events that were triggered and determine that events occurred. Let's see. By examining the send packet event type, you can verify the data, packet data and hex, and timeout heights and timeout timestamp. Or failure of the transaction based on the correctness of the data. You can determine the process of how the transfer occurs by looking at the coin received and coin spent. The coin received type indicates that when a user sends a coin through IBC, it goes to the receiver account, meaning it gets locked. Each your account spent and receiver account is IBC account. In the transaction events of osmosis, you will find a transfer module and log and found it. In this module, the recipient address corresponds to your account, while the sender represents the module account. It's a method where the module account sends token to you. Is sender and receiver account, recipient account. This module account is here. The role of this module account includes being a minter and burner. If someone wants to receive tokens, the module account acts as a minter, and if the tokens are sent back to the original chain, it functions as the burner. There are cases when IBC does not execute successfully. One such case when a timeout occurs. In the case, if the specified timeout block height or timeout timestamp has elapsed, it is necessary to revert the state transition resulting from the transmit packet. If tokens were sent, they would be returned to their original state. So this is how IBC send transaction is processed and displayed on Mintscan. Cosmostation is always making effort to display this kind of data more effectively, and we are about to launch Mintscan V2, which reflects these efforts. Mintscan V2 offers a wide range of diverse and structured data compared to the previous version. I will give you a little spoiler about relayer at Mintscan V2. Lastly, I'd show to you the dynamic IBC screen, which demonstrates how such IBC data operates within the Cosmos chain. Based on the following data, Mintscan V2 presents the dynamic IBC screen. Thank you.